Okay, today I'm going to talk to you about elasticity calculations. We're going to see how these two different calculations work and how they apply to a real life situation. Okay, so the first one we're going to look at is F equals K times X. To begin with, it's really important to know what this means. So I'm going to show you this situation here. Here we have a spring, and here we have the same spring after it's had this hanging mass added to it. So as you can see, the spring has been extended by the force of this mass here. So F stands for force in newtons. So here, let's imagine that this has a force downwards of 10 newtons. Okay. Next up, we need to know what this K represents. Now, K represents this thing called a spring constant. Now, the units for spring constant are newtons per metre. Now, all this thing a spring constant is it depends on the material that you're stretching. A stiffer spring has a greater spring constant. So this number here depends completely upon the type of spring that you're using. Now, finally, this X represents extension. So that's why the X comes in, extension, and it's measured in meters. Now, all extension means is how much has the spring extended. So this here is our X value, our extension. Now, let's say in this circumstance, it's 10 centimeters. Now, as you can see, because extension is measured in meters, we need to convert this to meters really quickly. So that is 0.1 meters. So quite often in an exam question, for example, you might be asked to find the spring constant from this particular situation. So with this force and with this level extension, what is the spring constant? Now, first of all, we have to do a little bit of rearranging. So the force is 10. Your spring constant, we don't know what that is. We're trying to figure out the spring constant of this particular spring. And finally, our value for our extension is 0.1 meters. Now, we need to rearrange this equation to make K the subject of the equation. In order to do this, we need to, at the moment, we've got K times 0.1 on this side. So in order to counteract that, we need to divide both sides by 0.1. So that's a 0.1 as well. So we're dividing both sides by 0.1. So on this side, we're doing 10 divided by 0.1, which therefore equals K. Okay, so I've basically done the same to both sides to make K the subject to the equation. Now, the next thing I need to do is 10 divided by 0.1, so 10 divided by 0.1, which equals 100. So in this particular instance, I'm just going to write it the other way around so it's nice and clear. So K equals 100 newtons per metre. Now, this value is just particular for this particular type of spring based on its stiffness. Okay, so the other type of equation, by the way, we need to, for Edexcel GCSE 9-1, we need to remember this equation here. We don't need to remember this equation here. We just need to know how to apply our knowledge to it. Okay, so let's imagine we're looking at the exact same situation, but now we know the spring constant. We want to see the work done during this extension. Basically, if there's a linear relationship between our force and extension, we can apply this equation to find how much energy is transferred during this extension. So right now, we're trying to find how much energy is being transferred during this extension. Okay, so all we need to do is put the numbers in. So we have, I'll just make that clear first. E stands for energy transferred. Okay, and that of course is measured in joules. Now it's also, another way of saying this is work done. So as the spring extends, how much energy is being transferred? How much work is being done? So now we know the spring constant, we just need to put the numbers into the equation. So E equals half. Now I prefer putting 0.5 when I put it into a calculator, times K. Now if you remember, K is the spring constant. This particular spring constant of this spring, we've just found out. It is 100. So we do 0.5 times 100 times x squared. Now this squared is really important. A lot of people miss this out when they put it into their calculator, okay? So remember the extension, how far the spring extended, was 0.1, and we square it. So all I need to do is put all of that into my calculator. Remember to put it all in at once. And because of BIDMAS, it does that squared first. So my answer is 0.5. So my energy, my work done, the amount of energy transferred is 0.5 joules. So here we've basically, just to recap, this equation, we can use the idea of force and extension to find the spring constant if we do a little bit of smart rearranging. And just here, we could find the energy transferred in a particular situation, as long as we know the spring constant and the extension as well. And remember, another term for energy transferred in this context is how much work is being done. Thank you.